Hello all. Today we'll solve the daily problem from Leetcode called the magnetic force between two balls. It's a simple problem to understand. So we have few containers given in the position array, and we need to place n balls in those containers such that the distance between any two balls is maximum. It can be unequal. It is meant to be unequal because the position array is not having equal distances. It can have a 1, it can have a 3, it can skip 4 and 5, it can have a 6 and 7. And it can be, m can be anything between that position size, maximum size that we can have. So in that case, if it would have been something like equal distances, right? 1, 2, 3, 4, 5, 6, 7, and then we have m balls. So we just need it to divide those m balls in these distances such that the distance is the maximum. That will be a simple problem. It will be just the maximum size divided by m. But in this case, we don't have that. And on top of that, the positions are not even sorted. Without sorting it, it's very difficult to solve this problem. So initially, we need to sort this position array. We'll sort it. Let's do it side by side. Position dot begin. So this is sorted. Now that this is sorted, this itself hints to something, right? It itself hints to something like, if we take this example, 1, 2, 3, 4, and 7. So now, if I take the maximum force to be 1, in that case, the first ball will be here. It will always be here. Because why not, right? We need the maximum distance, so we will choose the boundaries in any case. So the first position will be here. The second position, if there are suppose m23, the second ball can be here, right? Because I'm taking force to be 1. I'm already fixing the force right now, so I can try all the possibilities of what the force can have. The minimum value it can have is this force, and the minimum value it can have is this, right? So now that we are sorted, it's easier to get this, and uh, and this as well. This will always be 1, right? Because the minimum distance between two adjacent positions will be minimum 1, as given in the constraint. It cannot be, I mean, theoretically, it's not possible. Right? So right away, this gives a hint of it's a blind binary search problem, and the binary search is on the answer itself, that is force. So every time I do a binary search, I fix the force, and I try to place the balls, right? So initially, the first position, start force, will be 1, and the end force will be 1e. No, we can take this as well. I was about to take this, but we can just, since we have sorted the position array, we can just do or subtract between the last element and first element. And my initial result will be just 1, because this has to be the minimum force, because n cannot be greater than the position length. So this has to be the minimum force. So while start force, just follow the basic binary search template and will reach me answer. This is the max force. Instead of middle, I can use appropriate variable names. Max force seems to be appropriate. And that will be, since this may or may not start with 0, right? The first element can be anything in between 2 and 10 power 5. So we'll have to do it this way to find the middle element. Yeah, but this will be the max force. If the max force is, or if I can create a new function called if position, or just position, and this will have max force, definitely, position array, and end. If this gives me a true value, then all the balls are positioned. In that case, I should not break out because I may find a greater force, right? That is why we'll move the start force to max force plus 1. And before that, we'll store the result if it is greater than all the already existing value. Otherwise, I just is equal to max force minus 1, and now I'll return the result. And now we can create this function. This will take max force, comma, vector position, and the number of balls. Here you can try all the possibilities. And last, because I need to keep track of the previous elements so that I can keep track of the distances, I'll create a last element which will be usually the first element. Actually, this will be n minus 1. You know why? Because I'm already fixing this element as the first element, right? That's why this will be n minus 1. And now I'll just have a position for and I is equal to 1, I less than position dot size, I plus plus, and if the position of I minus the last position, if it's greater than equal to the max force, then I am good to place a ball here and I can decrease and now, and I can uh, update my last position now as current position, and I can return n less than equal to 0. If it's, I can already also add another condition here that n should be greater than equal to 0, or just greater than 0. This will give me either true if all the balls are placed and m is 0, otherwise it will give me false. So let's see, we are good to go. Position, yeah, yeah. So this works and it's very efficient. The time complexity, again, if you try to calculate, will be, you can also look at your, wait, I guess not, n log n because of the initial sorting plus n log of the maximum distance that we achieve between the two positions. The maximum distance will be this one. N force will be the value here. This will be the time complexity. Thank you very much.